All right. So it's 12 o'clock.
They signed the roll yet?
No.
You making one or?
Just
Alright.
anybody.
I excited. Put it
Uh, so, so we discussed chapter 1 on last time. All right. And we talked about units of measurement and units of measurement, right? That's the main thing. Units of measurement. So today, we're gonna jump right into conversions. Okay? So conversions is the bedrock of science, engineering, whatever. Right? If you can't do conversions, then we're wasting our time. Right? You have to be strong with conversions. All right? And it goes back to what I was saying about everybody agreeing on what something is. Right? Everybody has to agree on what something is. All right? So, as I always do, I like to, start with money, right? Because that's what we easily identify with. We identify easily with money, okay? And so if I had 100 million dollars. All right. I want to know how many pennies do I have in $100 million? How do I do that?
You gotta convert it to pennies, you said?
Yes.
So $1 has 100 pennies.
Yeah.
Okay.
I think you gotta go.
So $1.
You doing $100 bills first or?
No.
No, we're just doing
$1.
Yeah, that sounds like.
It'd be so you have $100 million.
yeah.
So
So I have 100. So I'm gonna start. So I'm gonna write that again right here, right? $100 million. And I'm gonna draw this like this. All right. And I'm gonna draw what we call a T-chart or a train track. Okay. And you said what? $1.
equals 100 pennies.
$1 is 100 pennies. Right? And so I should have wrote the dollar sign there just so somebody might $1, right? Let me write the dollar out in front. $1. Right? So this is what we called a conversion factor. This is a conversion factor. Right? That allows me to convert dollars to pennies. Okay? So, let's go back in the opposite direction. Let's say we have $100 pennies. And I want to know, well, no. Nope. That don't make sense, right? Let's say we got, even though this is not a real number, because it's not, you can't have less than 1 penny, right? But mathematically you can, okay? So let's say we got 1 times 10 to the minus 6 pennies, right? Obviously that's not a real number, right? Can't have less than 1 penny, right? But I want to convert that to dollars, right? Then it's the same setup, right? Only I start with what? What do I write before pennies? What number?
Oh, 10 to the 6, so 1 0.
So 1 times 10 to the minus 6 pennies, right? And then I use my conversion factor, right? Now, which one is on top and which one is on bottom?
The pennies on the bottom and the dollars on the top.
All right. So I'm gonna put 100 pennies on the bottom, and I'm gonna put the dollar on the top, right? Because the conversion factor represents 1. 100 pennies divided by $1 is 1. Y'all following me when I say that? So when we make other conversion factors, understand that the conversion factor must equal to the actual magnitude, the number must be 1. Okay? So let's go to something that we will be dealing with in mechanics, right? Which is distance, right? So 100 miles, and I want to convert 100 miles to millimeters. Everybody help me with that? 100 miles to millimeters. All right? You should get comfortable with the abbreviations, right? And miles is MI. $100 miles to millimeter.
You go to meters first. Yeah, that's what I'm trying to do.
And then we can go a number of ways, right? We can go a number of ways, okay? Well, I'm going to show you the way in which I want you to go, okay? And it's a reason why I want you to go this way, okay? And when you go this way, then, you can, it's hard to use, your little internet devices and stuff like that. Okay. So I'm gonna say we go to feet first. How many feet are in 1 mile? Nobody?
Isn't it 2,000 some feet than
Why are we guessing?
Well, I don't know the exact.
Why don't we just
Number.
use the phone?
5,280.
5,280. So 1 mile is 5,280 feet. So I'm gonna write my 100 miles here. And I'm gonna go to feet. How do I go to feet?
Go 1 mile at the bottom and
1 mile at the bottom, 5,280 feet at the top.
500.
All right, so miles and miles cancel. Now what?
1 feet.
1 foot what? 1 foot what?
You want the meters?
Feet.
Feet to
What y'all don't know what do y'all know about a foot?
12 inches.
12 inches in a foot.
Yeah.
1 foot is 12 inches. Right? And now we have
Each is 2 point.
now we cross out the feet. The feet cancel. And now we need a conversion factor
What about
from, hold on a second. Give me a second. Now we need a conversion factor which goes from, what system are these units in, by the way? Huh? English system. Right? We need to convert to what system? Metric. So we need a conversion factor. All right, and we already said what? We said 1 foot is equal to 12 inches. So we have some conversion factors here, but now we need a conversion factor from what? From an inch. All right, 1 inch is 2.45 centimeters. So this is the conversion factor, which allows us to go from English to metric and back and forth. Okay, this is the one I'm looking for. All right. So we got 1 inch. 1 inch is 2.54 centimeters. Now what?
1 centimeter. 10 millimeters.
1 centimeter is 10 millimeters. What's the number? Put it in scientific notation. You know how to change it on your calculator?
I don't think I got that.
You got it. It's a mode. Look for a key that says mode.
This got it?
You got it? 1.61 times 10 to the 8. What?
Millimeters.
Millimeters. Right? The centimeters cancel, right? Inches cancel. So in 100 miles, we have 1.61 times 10 to the 8 millimeters. Right? All right. So, and of course, we got another conversion factor of what? 1 centimeter is what? 10 millimeters. Right? All right. Let's convert 100 meters per second to miles, right? And we'll just write it out, right? Miles per hour. So what's the first step?
100 meters.
What about it? So we write 100 meters over 1 second. Right? So what are we gonna do?
We can change meters to inches.
You say we're gonna change meters to inches. Okay.
So there's 0.0254 meters in 1 inch.
Okay, that's so I know you probably looked that up, right? So like I said, I wanna matter of fact, we're gonna stick with these conversions, right? These are the ones we learned in grade school, right? Everybody knew this one, right? Everybody knew that it was 12 inches in 1 foot. Okay? Everybody, well, we should know, maybe not, right? And there's what? 1,760 yards in 1 mile. Okay? Let's see. So for here, when I see 100 meters, right? I know that meters are in what system? The metric system, right? And I'm trying to convert to a unit of what? Miles. That's in the what system? The English system. All right? So let's deal with the top part first, right? 100 meters, right? And I know in order for me to go from the metric system to the English system, I need to get here. Everybody following what I'm saying? This is the conversion factor that I'm looking for between the metric and the English system. Okay? So if I recognize that I need to get to centimeters, then I can convert 100 meters to what? Centimeters. How many centimeters are there in 1 meter? Huh? 100. Right? meters, right? And then you have what? Yes, sir.
Good afternoon. Is the
Uh-huh.
technology working in here?
Yeah, it was working earlier. Yeah. Yeah.
It's not working properly, but it's working.
Well, yeah, this one.
It's not. the
That one
screen
not
all the
coming
way up
down.
there. I use it from last night. It's not working properly.
Yeah.
It's not working properly.
All right. So centimeters, 100 centimeters, right? And so I have a conversion factor from centimeters to inch, right? So I can do what? Well, I'm gonna write right here. 2.54 centimeters. Gives me what?
1 inch.
1 inch. So now I'm at inches on the top. Right? Centimeters, centimeters. The meters cancel, right? I need to get to miles, right? So now I'm going from inch to what? Feet. 12 inches in 1 foot. And now I'm what? Feet to miles. Okay? 5,280 feet, 1 mile. So that takes care of what? Just the top. Right? Now we have what? Got to convert seconds into what?
Hours.
Hours.
So 1 hour, 60 seconds.
Okay. 1 hour is 60 seconds in 1 hour?
60 seconds.
60
I mean, 1 minute. I'm sorry.
Yeah,
My
yeah.
bad. 60 minutes an hour.
So 60 seconds
1 minute.
and 1 minute.
And 60 minutes an hour.
60 minutes and 1 hour. So now we at what? Seconds, minutes, miles per hour. What's that number? And I would suggest that you practice making these calculations on your own, right? And it's just a suggestion, all right?
Times 10 to the second.
Say what now?
2.24 times 10 to the second.
2.24 times 10 to the second?
That's what y'all got?
Miles. Is that, well, we're gonna just write that down and see if somebody come up with something different.
That's what I got. 100 divided by 1. I just got 2.24 times 10. It says to the 0.
You said what? You got what?
I got 2.24, but it says times 10 to 0, 0.
Well, somebody not right.
Yeah, let me recalculate again. Just in case.
So this is the point. This is why I suggest that you calculate these things on your own. So you can get comfortable with this and your calculator. Because everybody in here can come up with a different answer.
Did you want it like that or what I got, like answer wise? Because I got 18.64.
18.64?
I got the same answer as when I did. I got 2.24 times 10 to the second. I got 2.2.
3
Why
6
y'all put
times
it
10 to the 60.
I
Y'all
got
got it in scientific notation?
Yeah. I have a
Mine
question.
said 2.68 10 to 3.
So all right. So this is what we're gonna do. This is what we're gonna do.
Multiply the top.
So 100. There you go.
That's what I
Multiply the
would've
top
did,
and
the
then
top and then the
multiply the
bottom
bottom
too.
and then just divide the
Divide
Two.
by the width.
And that's what I got 18.64 when I did that.
Let me do that again.
You did that all on the same. Did you multiply it out? Write the number down.
Like
then
I
do
did
it?
100 times 100 times 60 times 60, and then I did 2.54 times 12 times.
But
5
did you
times
write the
10.
number down?
And then
Yeah, I wrote the numbers down and I just divided them.
I'm still doing it.
I
Even when I did it.
Sorry.
can redo it though.
So 100 times 100, right? That's 10,000, right? 60 times 60 is 3,600, right?
Yes.
So 10,000 times 3,600, right? That's gonna give us what? 36. 1, 2, 1, 2, 3, 4, right? 1, 2, 3, 4, right? 360,000, right?
No. It
No?
will give you 6 zeros.
Oh, did I do that wrong?
It should give you 6 zeros.
Oh, I missed a zero, right? 1, 2, 3, 4, 5, 6. Oh, 6 zeros.
It should be 36 million.
It should be 36 million. Yeah. My bad. Yeah. All right, 6 zeros. Yeah, 6 zeros. All right. And then we have what? 2.54 times 12 times 5,280. What's that number?
It should be 16,000, or no, 160,934.4.
What's the scientific notation?
1.61.
So we have 3.6 times 10 to the what?
7.
1 times 10 to the 7 divided by what?
1.61 times 10 to the 5th.
1.61 times 10 to the 5th.
Then it's gonna be 2.23 times 10 to the 12. 2.2.
No,
Well, how did
No.
no.
You sure?
7 minus 5 is 2.
Yeah.
So
what
you
is
so
wrong?
you said something wrong. Calm down. Calm down.
I must be doing.
All right? Something we did wrong. Calm down. All right? That's not a good. Emotions is not good in mathematics, right? You gotta calm down, because you'll get easily frustrated, and then everybody want to stop.
That's why I don't like
They're like,
it.
oh. All right. So, so what you said? What did you just say?
My answer after I calculated all of that was I got, I think mine was 18 point something, 18 point.
So when we did 3.6 times 10 to the 7, so are we using the E or are we using the multiplication sign? That's why it's wrong there. You have to use E. A multiplication sign will confuse the calculator. You must use E. Do you see E?
Yeah.
So this is 3.6. When you enter it in the calculator, it should look like this. That's where all the confusion is from.
So you can't just divide 3.6 divided by 1.61, and then, cause you know that 10 and the 7 and the 5 and the 2.
In your mind, that's not how the calculator works, though.
But I'm saying though, like when I'm dividing, can't I just divide the 3.6 divided by?
Yes, but then you don't need a calculator for that.
Right.
You talking about do the 3.6 and divided by 1.61 on the calculator, and then just do the tens in your head?
Yeah, because.
Yes,
Right.
yes, indeed.
So does our calculator need to be in degree or radian?
It need to be in degrees.
Alright, Professor,
Hmm.
I got a question. So I
Yes.
did what you just did with the E,
Uh-huh.
and I got a whole different number.
I know you did.
3.64 times 10 to the fifth.
Okay, well, you're not using parentheses or something.
Look, let me get up.
Listen. No, don't get up.
I just want to
Sit down. Calm down. Stay where you're at.
Alright.
Okay? Let me see, that's a TI. Let me see your calculator. Matter of fact, I'm gonna show you. Come, you watch what I'm gonna do right here. So you see this? See that? First of all, let's make sure you're in mode. And I'm gonna show all y'all this too, by the way. I can't show it to everybody. Alright? You're in radians. You gotta be in degrees. Enter. Okay? And you need to be in scientific notation. Alright? Enter. Now we're gonna second function quit that. Now we're gonna use parentheses. Open parentheses. 100 times 100 times, right? That's 1, 60, 60, 5, 60. Right? And we're gonna divide all of that, right? We're gonna divide all of that because I got the parentheses there. So it's gonna do everything inside of the parentheses first, right? And then I'm gonna open another parentheses for the bottom part. Because when I do that, it tells me do everything inside of the parentheses first before you divide. Right? That's what the parentheses say. 5280, close parentheses, right? Right. Enter. Okay? This is the answer. 2.23 times 10 to the 2. Alright? So whoever said this is it. Alright? 223 miles an hour. Okay? So that's why I suggest that you have that kind of calculator. Because the reason why everybody's getting different answers is because people are breaking it up differently. And we're violating the order of operations. I don't know if we recall that from math class in high school, right? But we can do the same mathematical equation and arrive at two different answers. All right? Y'all remember that? No? Yes? Okay. I feel like folks is getting frustrated already. I feel it in the room.
Is there not a TI like app on your
Yes, there is. You can download the TI-84 app. Yes. Yes. All right. Like I say. All right. These conversions, like I said, these conversions, they form the bedrock. We got to get these down. Okay? We cannot move forward in physics without these. All right? Any questions so far? Nope. Okay. So everybody understood that. Right? All right. That's good.
Oh, I got a question.
Okay.
So like, whenever you got like 2 units, you always gonna do what's on the top first?
Huh?
Like, you know how you just have meters per second, you gonna solve for meters first?
No, you can do the bottom. You can do the bottom first. Don't matter. Yeah, you can do the bottom or the top first. Don't matter. All right. How about let's convert some units of area, right? How do I convert units of area? Let's say I have, let's say, all right, my townhouse is about 1,300 square feet. 1,300 square feet. Let's convert that to, square kilometers. How we do that? And remember, I'm recording all of these things, right? So you can always go back and watch the video. But like I said, that's just a suggestion. Right? I don't micromanage people, 'cause I don't like people to micromanage me. Yeah. But like I said, we all gotta account for how we spend our time at some point. Yep. Right? Whether that be with me, yourself, your parents, God, somebody. We all gotta account. So I would urge you to do these things on your own. All right? I'm gonna be making some assignments in mastering physics to help you out. But again, right? I'm not forcing you. I'm not gonna force you. Like I say, I tried that approach in the past and it don't work. Not at this level. Does not work. Yeah. So, any questions? No questions? All right, good. So how we convert 1,300 square feet to square kilometers? I'm listening.
Square each. Square feet to square inch.
Well, that's good. I know what you're saying. But how about we do this? How about we just square that? Right? How about we just say 1 foot, right, is equal to what? 12 inches. And we just gonna do what? Square it on both sides. So we got what? 1 square foot is equal to what? 144 square inches. So we got a different conversion factor now. Okay? And luckily, right? Well, not luckily, that was intentional, right? So we went to that one because we got the square feet. We got the conversion factor, right? So we can go from square feet to what? Square inches, right? Yes. Right? So 1 square foot is 144 square inches. Okay? So now, bow, right? Inches to what? Centimeters. So we just gonna do what? We're gonna take that 1 inch is equal to 2.54 centimeters, and we square both sides. That gives me 1 square inch is equal to what? 6.5 something. 6.45 square centimeters. Okay? So now I have what? 1 square inch is what? 6.4554, whatever. 45 square centimeters. And last step, we go from what? Centimeters to kilometers. Or if that's too much for you, you could just stop and what? You go centimeters to meter, then do meters to kilometer. Right? But what is it? How many centimeters in 1 kilometer? It's 1,000 meters in 1 kilometer, right? So we go 2 spots past 1,000.
That's 100,000.
100,000, right? So, square inch, and we have what? 1 kilometer is 100,000 centimeters. Yes, sir. Then we square both sides, and we get what? 1 kilometer squared is equal to 100,000 squared, right? Centimeters squared, right? So 100,000 centimeters squared, that's what? 10 zeros, right? So, so we got 1 kilometer, 1 square kilometer. Let me write it out because some people might get confused. 1 square kilometer, square centimeters. So 1, oh no. Oh yeah, that's how I was doing. Alright, so yeah. 1, let's write it out. Yeah, oh, that's what I was trying to do. 1 square kilometer is equal to what? 1 times 10 to the 10, right? Square centimeters. So now we put that big number back here, right? So we say 1 square kilometer is 1 times 10 to the 10 square centimeters. Okay? Cancel them out. Now we at square kilometers. What's the answer? And you need to use parentheses and the E. If everybody uses parentheses and the E, then we'll get the same answer. And for those of you who don't have your calculator today, you need to bring your calculator every day. What's the
What y'all
answer?
got? I got 1.21 times 10 to the 16.
You got what?
1.21 times 10 to the 16.
1.21 times 10 to the 16 what?
Square kilometers.
Yes, square kilometers.
Kilometers.
No, that can't be right. This is only 1,300. I said my townhouse is 1,300 square feet.
Oh, well, okay, yeah, okay. Hold on, let me go back and do that. 1300.
What was your answer?
This ain't it.
I
Whatever
got,
that is, it's not it.
I got 2.659 e to the 10.
Okay, we're gonna have to try this again. So let's clear this out. Open parentheses, 1,300 times 144 times 6.45, right? Close parentheses, divide that by 1 second function.
So you don't do a parentheses right?
We gotta put the E, we gotta put a 10, right? See that E?
Where you press the E?
Second function, second, see the E,
Yeah, I was
E?
pressing the wrong one. I was
See that?
pressing the second.
No, not the little small E. Not the small E, y'all. Not the small E. Not this E right here. This E is an exponential. That's not for what we doing, right?
It might be a problem.
That's probably why. Okay. let me
It's
try
the
it.
big E on top of. It's on top of the comma.
I see.
You got to hit second function. If I don't know if this is on the TI. See, that's why I was saying I don't know.
X to the
There's-
negative 1.
There's one on this one too. It's just the x raised to the negative 1 on this calculator.
Okay. So let me finish doing this, and then I want to come look at that one. Insert. So I'm gonna do insert. Right. Where's insert? See, second function. Insert. Insert a parentheses there. That's all I did.
Yeah.
And E to the 10. Close parentheses.
Okay. 4.2.
This is the answer. Right? So how did I know that the first answer you gave me was incorrect? How did I know that? Anybody?
It was too big.
Too damn big. Extremely too big.
So you put the E, where did you put the E at again to get that?
You say where I put the E?
Mm-hmm.
This is what I type. I type open parentheses, right? We're gonna start from the beginning. Open parentheses. I don't know if you could do it on those though. I'm just thinking about it, right? But on that one, you probably just want to do the top first. Write that number down. Then do the bottom.
And keep it in degrees and scientific, right?
Yes. Then write that number down from the bottom and then divide the two. That's probably how you want to do it on those calculators. On the TI, you can put it in here just like this. That's why I urged you to get the TI. Yes. You should be able to just put it in here just like this. You got to make sure you're using the parentheses. Open parentheses. 1,300 times 144 times 6.45 times 1. Close parentheses. Then divide. Open parentheses. 1 times 1 times 1 times 1 times 10 to the 10. And when you do the 10 to the 10, you must use the E, the big E, not the small E. The big E.
You do 1 E and then to the bottom.
1, you hit 1, then you hit second function, E.
And then
Let me see your calculator. Let me see your calculator.
I don't know if anybody got the one I got, but it's the double E.
Yeah, the double
It's two
E.
E's.
Yeah,
It's two
yeah.
capital E's.
Yes, that's what it is. All right, so yeah, right here, right? So to write 1 times 10 to the 10, you would do 1, second function, that one. You see that E pop up?
Yeah. And then you put the
Then you
10.
put 10.
Okay.
That's it. Yeah, so that's a big issue, folks. Right? I mean, 'cause, folks get frustrated when folks getting different answers and stuff, right? They're like, oh, don't nobody know what they doing. It's violation of the order of operations. That's what it is. Okay, so when you put the parentheses there and you use the correct E, then we don't have those issues. Okay? All right. So expect to see some practice problems on mastering pop up pretty soon. And we're going to be entering into section 2 or chapter 2 definitely by next week, but maybe on Friday.
You gonna like put it on Canvas when you put the assignment?
Yeah, I think, doesn't it give you a notification when I post something? I don't know, it should, because it's integrated now. That's the reason why they integrated it, right? So anything I post on Pearson, it should give you a notification in Canvas. Cause they integrate. That's why you don't need no code no more. Right? Remember how we used to have the code?
Yeah.
That was cause you was going to sign up on their website. But now, they set it up where you do your registration through our website, through Canvas. You just how you signed up, you know what I'm saying? Because it's already paid for. So, did I answer your question?
Yeah.
Okay.
We dismissed.
Yeah, we done, y'all. It's 12:50.